Okay, so now we are at question 6. The diagram below shows a solid made from semicircular cylindrical base with a rectangular prism above it. The diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So this diameter, same as the width, so this is also 4 centimeters. So 12 centimeters. Right? This is 12. And this is also 4. So, right? So let's calculate the total surface area now. So, alright. So the total surface area, so I'm going to put area. Area equal to, so the area equal to, alright, so let's calculate surface area piece now. So for the top would be 4 times 12, alright, so the top will be 4 times 12, or 12 times 4, and that's the top up here, right, the top there. And the side will be 4 times 4, 4 times 4, the area. But this other side is also the same, is equal, so it's 4 times 4 times 2. That's the sides, this side. And then this side would be, so this is 4, so this is 12 times 4. And that's 2, because the opposite side would be the same area. Plus, so we have just calculated the area for the rectangular part, the rectangular prism part, right? So the cylindrical part now, the cylindrical part, the question gave us a formula. The question gave us a formula for the cylindrical part. Total surface area of a cylinder is 2 pi r square plus 2 pi r h. Alright? But remember, we are calculating is half of a cylinder. Alright? Because it's a circle, it's a part of a semicircle, as the question says, a semicircle. So we actually calculate surface area for half of the cylinder. So half of the cylinder would be 2 pi r square plus 2 pi r h. But we only want a half of that, alright? So times half. Let's fill in some values now. So A, so 4 times 12, that's 48. Plus 4 times 4, 16. 16 times 2, that's 32. Plus 12 times 4, that's 48, and 2, that's 96. Plus half of 2 times pi. Pi is what? 3.14 times r. Let's get the radius now. So the radius, no, here is 2. The diameter here is 2. So the radius, sorry, diameter here is 4, sorry. So the radius will be 2. Half of a diameter. So r would be 2. So 2 square plus 2 times 3.14 times 2 times the height. What's the height? The height would be, the height of the cylinder would be from here to here across. So, so that is 12. Alright, so the height, so 12. Alright. So from one end of the cylinder to the other end, so that would be 12. So times 2 times 12. So the calculation now. Calculator. So A. Alright, so let's do the addition. So 48 plus 32 plus 96, that's 176 plus half. In the bracket now, we have 2 times 3.14 times 2 square. That's 25.12 plus 150.72. That's 2 times 3.14 times 2 times 12. So the area is 176 plus half of the bracket total. That's half of 175.84. Half of that is what, 87.92. Add that to 176, we end up with 263.92. And this area, what's the unit? Centimeter? Was it centimeter? So area, so it's centimeter square. A square centimeter. Next, we're asked to find the volume of the solid. So the volume equal to area times height. We're talking about cross-section area specifically. So cross-sectional area, that's what the area represents, times height. Alright, so let's check back the diagram. We know the height is 12. We know the height is 12. And the cross-sectional area would be to the side here, this piece, so it would be the square part, so 4 times 4, so this part would be what, 16, 4 times 4, and then here would actually be a semicircle, so the area of our circle is pi r square, and it's a semicircle, so pi r square over 2, so half of the circle, right, or half pi r square, where r is what? R is half of the diameter, here is 2. Alright? So we're calculating the cross-sectional area now. So it will be 16 plus pi r square over 2. Half of pi r square. So it will be 16 plus half of pi r square times the height, which is 12. So the volume would be 16 plus half of 3.14 times 2 square times the height, which is 12. So the volume, let's work what's in the bracket. So everything in the bracket will equate to 22.28 times 12. So the area is 22.28, the cross-sectional area. Alright, 8, and remember the height is 12. Alright, so the volume is 22.28 times 12, and that gives us 267.36 is volume, so cubic centimeters. Next, we are told that the solid is made from gold. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. Calculate the cost to make the gold. So the cost to make the gold would be, so the cost is $42.62 per gram. So it's the weight in grams times the price, the cost of 1 gram, which is $42.62. Alright? Now how do we get the weight? Now we are told that each cubic meter weighs 19.3 grams. Each cubic meter weighs 19.3 grams. So remember is 267.36 cubic centimeters. And each of that would weigh 19.3 grams. So that would be the weight. Alright? Times the cost of a gram, $42.62. So we multiply these three values, we end up with $219,000, $921.25. At an entertainment hall, tables and chairs can be arranged in 2 different ways, as shown in the diagram above. Alright? So draw the diagram of 4 tables, using arrangement L. So notice arrangement L. So this is what, 3 tables. So if we have in 4 tables, add a table to that. And of course, no one would be seated here because these 4 tables will be joined. So here we have 2 persons to this side. We have 2 persons on that side. And here at the end we have 3 persons. Alright, so this would be the arrangement for L if we had 4 tables. Let's continue. To part B. The number of chairs C can be placed around a given number of tables T. For either arrangement, L or M forms a pattern. The values for C for the first 3 diagrams for both arrangements are shown in the table below. So study the pattern in each row of the table. Alright, so when you have arrangement L, 1 person will have 10 chairs, 1 table is 10 chairs, 2 tables, 14 chairs, and so on. Alright, notice the chairs are increasing by 4. And for arrangement M, notice the chairs are increasing by, that's 6. So let's see if we can complete this table. So of course the numbers are increasing by 4. So 10, 14, 18. So add 4, what would be now? 20, 22. Add 4 is 22. And we're adding 6 here. So add 6 here, we'll get what? 28. Alright, so for every table that will increase arrangement L, 4 more chairs. Every table will increase arrangement M, 6 more chairs. So we're asked what would be the number of chairs, number of tables that would give us 130 chairs for each arrangement. Alright, so the wise thing to do here would to try and get the pattern. Notice, let's deal with arrangement L. Notice in arrangement L, the number of chairs are going up by 4. So they're increasing by 4. So of course they're linear, it's increasing linear. Alright. Arithmetic progression here. So 4. So of course we can call it 4n. So if we multiply, notice how you get from the number of tables to number of chairs. For L, let's focus on L. Increasing by 4. So 4 by n. So 4 by 1. And how we get 10. Plus 6, let's try that. 4 times 1. 4 plus 6, 10. It has to work for all of them. 4 times 2, 8. Plus 2, sorry. Plus 6. My bad. Plus 6. So 4 times 2, 8. 8 and 6, 14. 4 times 3, 12. So 4n plus 6. So the rule here would be 4n plus 6. Alright, so to get from the values in the first column to the values in the second column, we multiply by 4 and add 6. And this is for arrangement L. For arrangement M, let's see, of course we're going up by 6. So the chairs will be 4 times, well, we're going up by 6. So 6 times n. So let's test it. So 6 times 1, we add 4 to get 10. 6 times 2, does it work? 12, 12 plus 4. So 6 times n plus 4. So this arrangement, the rule generally will be 6 times n plus 4. So to get from the values in the first column to the values in this third column, arrangement M, you multiply these values by 6 and add 4. And for the middle column, you multiply the first column values by 4 and add 6. That seems to work for all of them. So we still need to work out the number of these missing values. Alright. I guess we could use these formula now. Values is for 130. Alright. So 130, we want to get the number of tables for arrangement M. So arrangement M, the rule here is 6n plus 4. So we equate 6n plus 4 to 130. We subtract 4 from both sides, so we end up with 6n equal to 130 minus 4, That's 126. So we subtract 4 from both sides. Divide both sides by 6. We end up with n equal to 21. So this will be 21. This will be 21, right? And then to get this middle value, remember how we get these middle values again? You multiply this first column by 4 and add 6. So 4 times 21, that's 84. 84 and 6, that's 90. Alright, so this should be provide us with the missing values. Next, we are told that Leon needs to arrange tables to seat 70 persons for a birthday party. Which of the following arrangements, L or M, would allow him to rent the least number of chairs? So Leon have no whole heap of money, so he want the thing at the cheapest possible rate. So which arrangements can he use with allow him to use less chairs? So let's look at arrangement L. Let's look at arrangement L and arrangement M separately. If he uses arrangement L, 4n plus 6 equal to 70. Subtract 6 from both sides. We end up with 70 minus 6, which is 64. Divide both sides by 4. N is equal to, what's 64 divided by 4? 16. So if you use arrangement L, you would use 16 tables. If he uses arrangement M, so 6n plus 4, equate that to 70. Subtract 4 from both sides. So 70 minus 4, that's what, 66. Divide both sides by 6. N is equal to 11. Alright? And remember from the table, n represents the number of tables. Alright? N represents the number of tables. Which arrangement would allow him to use the least number of tables? And that would be arrangement M. Arrangement M. So the answer would be arrangement M. So the answer would be M. Alright, since he will use 11 chairs. Instead of 16 if he uses arrangement L. Alright, so arrangement M permits him to use 11 chairs and still will be able to seat 70 persons. Alright, if he uses arrangement L, he will only be able to seat he will need 16 tables. Alright, so arrangement M is it. Next question is question 8, section 2. I don't know why CSEC do this, because all the questions are compulsory. So just 10 questions, answer all 10, right? So 8 questions, alright? A rental car company, question 8, has X cars and Y minivans, alright? The company has at least 8 vehicles together. The number of minivans is less than or equal to the number of cars. The number of cars is no more than 9. Write down 3 inequalities in terms of X and Y other than X greater than or equal to 0, Y greater than or equal to 0 to represent all of this information here above. So let's go again. So we're using X for cars and we're using Y for minivans, right? X for cars, Y to represent minivans. Alright? Alright, so this seems to be a linear programming problem. Alright, let's write down the inequalities. So the company has at least 8 vehicles together. So when you add up the amount of cars, represented by X, and you add up the amount of minivans, at least 8 vehicles together. So it's either 8 vehicles or more. Alright, so greater than or equal to 8 there. To represent at least. The number of minivans is less than or equal to the number of cars. So minivans is what? Y. So that's less than or equal to the number of cars there. They are represented by X. Next, the number of cars must not pass 9. There must be no more than 9. Cars is what? X. So the number of cars can be 9 or less, but must not be more. Alright, so we use less than or equal to. So I guess these will be the 3 inequalities. Alright, to represent the information there above. Let's see what we are asked now. I'm guessing we'll be asked to sketch these inequalities. No, not yet. A car can carry 4 people and a minivan can carry 6 people. There are at most 6 persons to be taken on a tour. Show that 2x plus 3y is less than or equal to 30. So a car can carry, car was what again? Car was x. A car can carry 4 people, so 4x. So one car would carry 4 people. If x is 2, you'll get 8. 2 car will carry 8 people, and so on. Alright, and a minivan, 6y. Alright, and that must be less than or equal to at most, so 60 or less. So less than or equal to 60. Good. And then we want to show it, we get this, so I guess we can divide each term by 2. So if we divide each term by 2, we end up with 2x plus 3y less than or equal to 60 divided by 2 is 30. Alright, so we get what we're asked, so hence proven. Alright, so we get what we're asked to show. Or hence shown. Alright. Next. I guess now we'll be asked now to do a sketch of all these diagrams, all these inequalities, the representative line. On the grid below, plot the 4 lines associated with the inequalities in A and B. So again, the first inequality, let me just draw the inequalities. So one of them was x plus y. Alright, so to represent this inequality, we'll draw the line x plus y equal to 8. So this line will cut the x and the y axis both at 8. Alright, so x plus y, so you cut the x axis at 8. And it cuts the y axis at 8. Okay, so doing the problem on another graph. Alright, so we need to sketch all the lines associated with these inequalities. So x plus y equal to 8 will be this first line. Alright, so this line cuts the x-axis at 8. Also cuts the y-axis at 8. So let me just draw this line. So this is a graph of the line x plus y equal to 8. Now greater than 8, my bad, greater than 8. So if we were to shade, we'll shade above the line. Alright, but we're not shading it. We want to draw all the lines first. Y equal x would be the next associated line. And this line cuts through. So this line passes through points like 1, 1, 2, 2, 3, 3. So whatever the x coordinate is, the y coordinate is the same. Alright? So these lines will pass through all these points. So this is a graph of the line y equal x. Less than, so we'll shade below the line, but we're not ready as yet. Next line, x equal 9. So this line cuts the x-axis at 9. So let me just put the x-axis at 9. So this line would resemble something like that. That's a graph of the line x equal 9. Less than, so we shade to the left. And the final line, 2x plus 3y equal to 6. And of course, we need to know where this line cuts the x-axis and the y-axis to draw it. So this line cuts when the y is 0, you have 2x equals 60. Divide both sides by 2, you cut the x-axis. Sorry, 2x. Oh, that's not the line. It's 30. Right? So 2x equal to 30. Let the y be 0. So we have 2x is equal to 30. Divide both sides by 2. X is 15. So this cut the x-axis at 15. Alright. Now we need to know where the line cuts the y-axis. So you let the x be 0. So you end up with 3y is equal to 30. Divide both sides by 3. Y is 10, so you cut the y-axis at 10. So this line will look something like this. Cut the y-axis at 10, x-axis at 15. And it's less than. So the area, this will be the area represented then. The area represented by all the 4 lines. So the question asks us to, after we have plot the 4 lines associated with the inequalities, we're asked to shade the region, which we just did, and to label the region R. All right, so we'll call this region R. Next, we're asked to determine the 2 combinations for the number of cars and minivans that can be used to carry exactly 60 people on tour. So recall that we're told that 4x plus 6y less than or equal to 60. So we want the combination of x and y that would take up to exactly 60. Alright? So let's look at the critical region for the graph. These will be the critical region. Let's write them down. This critical region here would be 6, 6. Other region here would be 9, 4. And these are the vertices in the shape R, right? This region is what? 9, 0. This is what? 8, 0. And this is 4, 4. Alright, let's copy all these points to the question, the possibilities. So these are the points we identify, the critical points we identify on the graph there. So which combination of xy values give us 60? So you can trial and error there. But just to, what you'll realize is that 4, 4 and 6, 6 will give us 60. So if we try 4, 4, if we substitute 4, 4, you end up with 4 times 4 plus 6 times 4. Replace x with 4 and y. So that wouldn't work. 4, 4, 16. 6 times 4 is 24. Of course, you wouldn't get 60 there. Alright? Let's just try 6, 6. If I try 6, 6, so this would be 4 times 6 plus 6 times 6. Alright, 4 times 6 is 24. 6 times 6 is 36. Add these two values, we get exactly 60. So this combination definitely will work. And let's try 9, 4. If we try 9, 4, we will have 4 times 9, which is, what's 4 times 9? 36 plus 6 times 4, 36 and 24, again we'll get exactly 60. So these combinations give us 60. So remember, we're told a car can carry 4 persons and a minivan can carry 6 persons. And remember, car was represented by x, and that's why we use 4x. And for car, minivan, sorry, 6y. Alright, so the combinations below here, the combinations we have here, where are they again? So 6, 6 and 4, 4 will ensure we have exactly 6 persons in the car, 6 persons in the minivan will give us 60 persons, 9 persons in the car, 4 persons minivan will give us 60 persons also. Yes, that came out wrong. Alright, so 4 cars and 6 minivans will ensure that we have 60 persons. Likewise, 6 cars and 6 minivans. Alright, will ensure we have 60 people on tour. Alright, next question. The company, next section, the company charges $75 to rent a car and $90 to rent a minivan. Show that the minimum rental cost for this tour is $9.90. So rental costs. Alright, so 75 for a car. So 75 times X. Car was represented by X, right? And 90 for a minivan. 90 times Y. And remember the combinations were, 6, 6 or 9, 4. If you want 60 persons on the tour. Alright, so which one will give us the least smaller value? Let's try both of them. Let's substitute 6, 6. If we substitute 6, 6, would have the rental cost. The rental cost would be 75 times 6 plus 90 times 6. And if you substitute 9, 4, the rental cost would be 75 times 9 plus 90 times 4. So we will end up with, for the 6, 6, we'll end up with 1035 if we rent 9 cars and 4 minivans. So it works out better if we rent 6 cars and 6 minivans, since the cost would be $9.90 in that case. So question 9 is a circle theorem problem. So what are we told now? O is the center, MK is the diameter, and MK is diameter, which is parallel to HJ. Where is HJ? HJ, yes, HJ. And what else? MJ equal to JL. MJ equal to JL. I guess MJL is an isosceles triangle since MJ is equal to JL. What else are we told? JMK is 38 degrees. Alright? So we are asked to find angle. Explain given a reason why angle HJM is 38 and so HJM. So we are given the angles. So HJM we are told is 38. So HJM, so this angle we are told is 38 degrees. Alright? The reason would be this angle HJM is alternate angle to JMK. So, alright, HJM is alternate to this angle JMK. Next, we are told MJK is 90. Which angle is MJK now? MJK is 90. MJK, so MJK, that's this angle. Notice this angle is formed from the endpoints of the diameter to meet on the circumference, and that's a alright, that's a circle theorem. Alright, so the angle MJK is formed from the endpoints of the diameter to meet on the circumference. Alright, that's what makes MJK 90. Next, angle, determine the value of each of the following angles now. So they give us some and they give us some and they ask us to work out some ourselves. MLJ, angle MLJ, let's go back up to the diagram. MLJ is the angle we want. MLJ, let me put it here, just to remind myself. MLJ. Alright, let's work it out now. Alright, if we can work this angle out at K here. Notice this is a right angle. So if this is a right angle, so if we focus on angle and triangle MJK, it's a right angle. So all the angles should add to give. All the angles should add to give 180 degrees, right? So if I add this 90 plus 38 plus angle K, I should get 180. Alright, 90 plus 38, that's what, 128 plus K give me 180. If I subtract 128 from both sides, K is 180 minus 128, that's 52. So this angle is 52 degrees. Now, what's the significance of that? MLJ, this angle, notice MLJ, they are in the same segment. Notice, look at MJ. Look at MJ. Notice the angles, look at the endpoints of the chord MJ. Meet at K, that's 50. Now we have two more lines coming from the same chord MJ to meet on the circumference. Alright? So these are angles in the same segment. Hence MLJ would be 52 degrees. The next angle we're asked to calculate is angle LJK. Let's go back up to the diagram. Okay, so LJK is the next angle we're asked to find. Good. So LJK, which angle is that? LJK, that's this angle. That's this angle. Now, we're given some information. We're told that triangle LJM is an isosceles triangle. Since JM is equal in length to JL, so it's an isosceles triangle. All right. So the opposite. So this angle would be 52. All of this would be 52. All right. So hence this part would have to be 14. This angle would have to be 14 degrees. So you'll notice that these two segment, this chord. If you draw a chord here from L and K, just draw an imaginary chord here from L and J. From L and K, sorry. Notice to meet at the circumference, that's 14. And then these same two lines from L and K meet at the circumference. Alright, so say angle in the same section, so this would have to be 14. So LJK would have to be 14 degrees also, since it's the same segment as KML or LMK. Alright, equal LMK. They are in the same segment. The next angle we're asked to find was angle JHM. No, going back up to the diagram. JHM, which is angle JHM, that's this angle. And this angle should be fairly straightforward. Notice we have a cyclic quadrilateral there. So we have a quadrilateral. Look, if you look at MHJL. And so we have a quadrilateral there, alright? These 4 points here, all on the circumference, form a quadrilateral. So the opposite angles on the cyclic quadrilateral, they add to give 180. So JHM, so 52 plus this angle should add to give 180. So this angle will be 180 minus 52, which is 128 degrees. Alright, so it's 128 degrees. So these two angles must add to give 180, since they are opposite on what we call a cyclic quadrilateral. Let's move to part B. From a port L, a ship R is 250 kilometers on a bearing of 65 degrees. So remember, we always take bearing from the north. So this is 65 degrees. Ship T is 180 degrees, 180 kilometers from ship L, and we can see that in our graph. Ship L to T, that's 180 kilometers. All right. We're also told that a ship T is 180 kilometers from L on a bearing of 148 degrees. So ship T is 180 kilometers from L. Alright, so it's from L. Alright, on a bearing of 148 degrees. Ship T. So from L, so it's 148 degrees. So this angle inside would be 148 minus 65. Alright, so 148 minus 65 will give us 83 degrees. So what are we asked to calculate now? So complete the diagram, we just did that. Calculate RT, the distance between the two ships. So I guess we can use cosine rule to get a distance RT. Let's apply the cosine rule to this. Alright, so applying cosine rule. So RT square, where can I put it? So RT square is equal to the sum of the other two sides square, which would be 180 square plus 250 square minus 2 times these very same sides, 2 times 180 times 250, cos the angle between these two sides, so cos 83 degrees, which means that RT square, and you don't need to write this piece in your calculator. In one go, your calculator should be able to perform this calculation. Let's do the calculation. So this gives us 931.76. So RT would be the square root of that, which is 289.7 kilometers. Alright, so that's RT, 289.7 kilometers. Next, we're asked to determine the bearing of T from R. So the bearing of T from R. So the bearing of T from R. So from R, I'm going to draw a line there. Let's change the color. So we draw a line north of R. And this is the angle we want. Alright, that's the angle we want. Now how can we get this angle? Now if I extend this line, this north line come. Now notice I can use the sine ratio to get this angle. Alright, let me give this angle a name. Let me call this angle X. Alright, so I can use the sine ratio to get this angle. Use the sine ratio, so the angle, so sine of the angle, so sine X over the opposite side, which is 180, is equal to sine of another angle, so sine 83 over its opposite side, which will be 289.7, and I can multiply both sides by 180. I can multiply both sides now by 180. These 180, so I'm left with sine X equal to sine 83 times 180 divided by 289.7, which would give me 0.62. So X would be sine inverse 0.62, which would amount to 38 degrees if I'm using the nearest degree. So this angle will be 38 degrees. Now if you'll remember so all of this 65, this 65 is the alternate angle to all of this will be 65, x on this angle. So this piece would be, if I subtract 38 from 65, I'm left with what, 27 degrees. Alright, so this piece would be 27 degrees, since both of them give us the alternate angle here of 65 corresponding here. So the bearing would be, so from here to here, that's 180 degrees plus this 27 degrees. So to answer the question, the bearing will be 180. So the bearing of T from R is 180 plus 27 degrees, which that's 207 degrees. And now we're at the final question, question 10. The transformation represents a rotation of 90 degrees clockwise about the origin. The transformation B represents a reflection in a straight line with the equation y equal negative x. Write the coordinates of P image. The image of P after it undergoes a rotation of 90 degrees anti-clockwise about the origin. So P image will just be, what's the transformation? P image rotation about 90 degrees, that's this one. So to multiply A by P, because A represents a rotation anti-clockwise 90 degrees about the origin. So P image will be A, which is 0, negative 1, 1, 0 times the coordinate P, 7, 11. So do this multiplication. So 0, negative 1 times 7, 11 with 0 plus negative 11, which is negative 11. And 1, 0 times 7, 11 will be 7 plus 0, which is 7. So the coordinate would be 11, 7. Negative 11, 7. Next. T is the combined transformation of A followed by B. Determine the elements of the matrix representing the transformation T. So T is A followed by B, so AB. Alright, so A was what? A was 0. A was 0, negative 1, 1, 0. A followed by B. Followed by B. When we're doing the combined transformation, we reverse the order. So A followed by B. So we're doing BA. Alright, let's reverse the order. So T would be BA. So B, what's B? B would be 0, negative 1, negative 1, 0. And A, what's A? A will be 0, negative 1, 1, 0. So we'll do the multiplication. So row by column, so 0, negative 1 multiplied by 0, 1, 0 plus 0. So it will be 0 and negative 1 times 1. So it's 0 plus negative 1, which is negative 1. And then we top row again by the second column. So 0 times negative 1, negative 1 times 0, that's 0. Then we apply the bottom row now to the first column. So negative 1 times 0 plus 0 times 1, that's 0. And then the bottom row to the last column, that's negative 1 times negative 1, that's positive 1 plus 0 times 0. So that would be our matrix T. Describe geometrically the transformation represented by T. And this is a reflection in the y-axis. One way you can check, instead of swatting this thing, one way you can do is just try it on a random point. Just try a random point, like say for example 2, 1. So let's apply it to 2, 1. Let's apply T to a random point 2, 1. and see what happens. If I multiply t by 2, 1, you'll end up with negative 1, 0 times 2, 1, that's negative 2, and 0, 1 times 2, 1, that's 1. Notice when you apply the matrix to 2, 1, what happened? The x coordinate changes. Alright, the x coordinate changes its sign, which would mean that's a y-axis reflection. If you look at the graph there, for example, you have 2, 1, 2, 1 will be this point here, 2, 1 will be this point here. When a transformation is applied there, you end up with the point negative 2, 1. So notice here is that the y-axis would be like a mirror line. So it is a y-axis reflection. Part B, so we have a matrix there. Determine the value of k given that c is singular. Alright? So if c is singular, determinant of c is equal to 0. If c is a singular matrix, so 3k, 6, 4, determinant is 0 if it's singular, so cross multiply diagonals and subtract. 3 times 4, that's 12, minus 6k equal to 0. So 12 equal to 6k, divide both sides by 6, so the value of k is equal to 2. Next. So we are on to the vectors section. So in the diagram below, OX is equal to U, as we can see there. The vector OY is equal to V. Alright. X is a midpoint of, X and Y are the midpoint of OA and OB respectively. Alright, so we're asked to express BX, so find the vector BX. So BX would be from here to here. That should be a straight line vector there. So BX, using the triangular vectors here, so BX would be equal to BX, going from B to X, would be equal to BO, the vector BO, plus OX. So to get from B to X, so B to O, and then O to X. Now remember that Y is in the center, so this is also B to Y would also be V. So B to O, so O to B, if you notice O to B, OB is really 2V. This V and another V, so it's 2V. So BO direction changes, so it will be negative 2V. Alright, so BO will be negative 2V. Since we're going from B to O, opposite to OB, alright? And OX from here to here, that's just U. Next. We are told that YA and BX intersect at M and BM. So this is a bag of things this saying. Let's just check it. YA and BX intersect. Let's just check it. So YA, we are told that YA and BA intersect. YA and BX intersect. And they intersect at M such that BM equal to MX. So they intersect at M. They intersect at M such that BM equal to MX. And we're asked to find the vector BM. So BM equal to MX. So we can cut this into 3 sections. So B to M is the length. So this is each of these thirds. So X to M. Alright, let me call this point P. Give it a name. Let's call this point P. So B to P is same as P to M, same as M to X. Alright. So that's that. So we need to find the vector BM now. So one strategy we could take is find BX. So BX, I'm going to find BX. So BX is equal to B to O plus O to X. But we found BX already. So, yeah, we found BX already. So to get BM should be straightforward then. So BM is just 2/3 of BX. So B to M would be just 2/3 of BX. So b to m will be just 2/3 of bx. Alright, so 2/3 times, and we found bx to be u minus 2v. So we can expand that. We get 2/3 u minus 4/3 v. Or of course you could have used 2/3 negative 2v plus u. Alright, so notice same as u minus 2v. I'll just rewrite bx, put in the positive u at the front, but either way it's still okay. And the final section, show that ym to ya is in the ratio 1 to 3. So ym, if we divide ym by ya, we should get 1/3. Alright, so we need to find ym and ya. Now from the diagram, the vector ym is we could write the vector ym as yb plus bm. So yb plus bm. No, what's yb? yb, that's v. And bm, did we find bm? Of course we found bm. Bm was what again? Bm was, yes, bm, 2/3 u minus 4/3 v. U minus 4/3 v. So if we group the v, we have 1v minus 4/3. So we have 2/3 u, and we have 1v minus 4/3 v. That's negative 1/3 v. Alright. We also need ya. Did we find ya? I don't think we have ya, but ya would be yo plus oa. From the diagram, y to a, y to o to a. Now yo, that's negative v, since you're going the opposite direction. Oy is v, so yo is negative v. And oa, remember this is also u, x to a is also u. So oa would be 2u. So let me rearrange it into, put the positive value first. So this is 2u minus v. Alright, so ya. And then let me just, can I factor out 1/3? Let me just come back to ym. Factor out 1/3. So factor out 1/3. I'm left with 2u minus v. Alright, so ym is 1/3 2u minus v, and ya, so the ratio, let me do the ratio right here, do the problem right here. The ratio of ym over ya, so therefore ym over ya, ym is 1/3 2u minus v, and ya is 2u minus v. So these are the same, so they divide into each other to give 1. So ym over ya give us 1/3. Alright, so we have just shown that the ratio ym to ya is really 1/3. That's it. See you next time.